talk about 2.7, derivatives and ways of change. First, we're going to talk about tangent. If this curve C has this equation y equal to f of x, and we want to find the tangent line to this curve at this point P, we consider a nearby point. Okay. So let's say a nearby point Q here, where this Q here has x coordinate to be x, y coordinate f of x. Where this x is not the same as this a, so they're not the same point. We compute the slope of the second line PQ. According to the slope formula, will be y2 minus y1 over x2 minus x1. So that will be equal to f of x minus f of a over x minus a. And then we let this q approach p along this curve by letting this x approach to a. So when you move this q along the curve approach to p, the x is getting closer and closer to a. If the slope for this second line here approach a number, say m, then we define the tangent line t to be the line that go through p with the slope equal to m. So, and we define the slope for this tangent line to be the limit of the slope for this second line when you move this q along the curve, getting closer and closer to this point P. Okay, and now what is this slope for the tangent line equal to? Well, when you move this q along the curve closer and closer to P, x is getting closer and closer to A. So we're taking, so that's the same as we're taking the limit as x approaching to A. Now the slope of the second line PQ, we just got it over here. It is f of x minus f of a over x minus a. So the slope of the tangent line is defined to be the limit of this quotient as x approaching to a. So this is the formula for the slope of the tangent. So this is the first formula for the slope of the tangent. Now, if we let this point Q, instead of using x to represent its x coordinate, how about we let h to represent the x coordinate of this, subtract the x coordinate of this. If we let the x coordinate of this q to be a plus h, where h is the difference between this one and this one. So when q is on the right side of this p, h is positive. When q is on the left side of this p, then h will be negative. So we let a plus h to be the x coordinate for this point q, and the y coordinate of this point q here will be f of a plus h. Now, as x approaching to a, we can see that the h here is approaching to 0. Now, this quotient over here will be the same as f of a plus h minus f of a over a plus h minus a, which is this h over here. So this is y2 minus y1, and x2 minus x1 is this h over here. Now, this is the second formula for the slope of the tangent, and they're equivalent. Okay. Now, this example, f of x is equal to x squared. We try to find the slope of the tangent at this point. This point over here is on this curve. It satisfies this equation. Now, let's use the formula 1 to calculate the slope of the tangent at this point. So that's equal to the limit as x approaching to a, f of x minus f of a over x minus a. Now in this case, a over here is 1, x approach to 1, and this is f of x minus f of 1, and x minus 1, because a equal to 1. Now, to find this limit, we're going to use this function. Remember, this function is f of x equal to x squared. So this will be limit as x approaching to 1. F of x is x squared. F of 1 is just 1 squared. lim x minus 1. Now to find this limit over here, we will factor the numerator using the different two square formula. Okay. So we factor the numerator over here. Now notice that if we substitute 1 into the x over here, you get 0 over 0, which is indeterminate. So we would like to factor the numerator, x squared minus 1, using the difference of two square formula. So that we x minus 1 times x plus 1. Now divide by x minus 1. This x minus 1 is a common factor that you can divide out. So leaving you with this x plus 1. Now this is a polynomial. X plus 1 is a polynomial. So we can go ahead and substitute 1 over here. So we can do a direct substitution. Substitute 1 into x. So we got 2. So we found that the slope of the tangent at this point 1, 1 on this curve is equal to 2. Okay. Now let's use the second formula to calculate the slope of the tangent at the same point. So that's equal to the limit as h approaching to 0, f of a plus h minus f of a over h. That was the second formula. Now we're going to use this f of x equal to x squared. So f of a plus h is a plus h squared. F of a is a squared. Now if you do a direct substitution, substitute h to be 0, you're going to get 0 over 0, which is an indeterminate form. So there are two ways to take care of this indeterminate form when you get this 0 over 0. In this case, you can either factor the numerator and then divide out the h, or you can expand this perfect square over here, use the perfect square formula. So let's first expand this perfect square over here, use the perfect square formula. So that will be a squared plus 2ah plus h squared. Now subtracting a squared over here, the a squared are going to be cancelled, giving you 2ah plus h squared. Now when you divide by h, the h is going to divide out, giving you 2a here plus h over here. Now another way to get out of the indeterminate form over here is you can factor this numerator using the different two square formula. So that will factor into a plus h minus a times a plus h plus a divided by h. Notice that this becomes h. So the h over here are going to be divided out. So that will give you some limit over here. You will have the same result. Okay. Now notice that over here you have a and h. This limit over here, only the h is changing. H is approaching the 0. We got this a here as a temporary constant. So only the h here is changing. So substitute h to be 0 here, you get 2a. So we found that the slope of the tangent at any point on this curve where the x coordinate is going to be a, is going to be 2a. So at this point 1, 1, a is equal to 1. So the slope will be equal to 2a. And a is equal to 1, so that will be equal to 2. Now, at another point on the curve, like 2, 4, a is equal to 2, so the slope will be equal to 2a, which is 2 times 2, so that will equal to 4. So if you have multiple points on the curve that you want to calculate the slope, it is better that you calculate the slope this way. So later on, you can substitute different a into this expression to calculate the slope. Next example, f of x equal to 3 over x. Try to find the slope of the tangent at this point. This point satisfies this function, so it is a point on the curve. So let's use the first formula. M equal the limit of f of x minus f of a over x minus a. Okay. Now we're going to substitute. So a is 3. So we substitute 3 into a. Now this function is f of x equals 3 over x. So this is the limit as x approaching to 3. F of x here will be 3 over x. F of 3 here is 3 over 3. So we got this limit over here. Now notice that if we substitute 3 into x here, you're going to get 0 over 0 type, which is an indeterminate form. And notice that this is a complex fraction. So remember we talked about when we take the limit of complex fraction like this, of this indeterminate form, we can multiply the LCD of all of them over here. So then we can get rid of the denominator over here. Okay. Now first we simplify. This is 3 over x minus 3 over 3 is just 1. Down here is x minus 3. We mentioned before, when we have take the limit of complex fraction like this, if they're of this type, one way to deal with it is to times the LCD of all up and down. So you see the denominator x here. If I times x up and down, that will cancel out with this x here. So we can simplify it that way. So we multiply by this x up and down. That way, when you distribute, x times this gives you 3, and this is minus x. Down here you have x minus 3 times x. Notice that this 2, 3 minus x and x minus 3, they are opposite. When you divide out opposite, you get -1. Okay. So this is going to simplify into -1 over x. When we take the limit as x approaching to 3, we can do a direct substitution, and this is going to become -1/3. So we found the slope of the tangent is equal to -1/3 using the first formula. Now we can use formula 2 and see if we get the same result. Formula 2, the slope of the tangent is equal to the limit as h approaching to 0, f of a plus h minus f of a over h. Now we're going to substitute this a plus h into this x over here. So this is going to become 3 over a plus h. Now this point over here is on the curve. A is equal to 3. F of x is 3 over x. So f of 3 plus h is going to be 3 over 3 plus h minus f of a is f of 3. F of 3 is going to be 3 over 3, which is going to be a 1. Simplify, we get this -1. And down here is h. We have this complex fraction over here. And if you substitute h to be 0 here, you get 0 over 0. So when we have this complex fraction, and the limit is of this 0 over 0 type, one way to deal with it is to multiply the LCD up and down. So the LCD here is this 3 plus h. So times 3 plus h up and down. Now distribute. This times that give you 3. This times that give you minus parenthesis 3 plus h. And down here we get h times 3 plus h. Simplify the numerator on top. We got -h. -h is going to divide out with this h. And we got -1. So simplify, we got -1 over 3 plus h. And we're taking the limit of this. Now we can do a direct substitution. Substitute h2 with 0 here. We got -1/3, which is the same result as we're using formula 1. So you can use either formula 1 or formula 2 to calculate the slope. So after this example, I want to point this out to you guys. So for limit of a quotient, and if this quotient over here is a complex fraction of type 0 over 0, then one way to deal with that is we can try to times the LCD up and down to simplify that complex fraction, and then later on you can divide out the common factor up and down.